Hello, I'm Daniel Albu. Welcome to Mastering HTML5 Game Development by Pact Publishing. I've been an interactive developer for the past 12 years. I've worked mainly with Adobe Flash until a few years ago when I switched to web development using pure JavaScript and CreateJS, and native app development using Java for Android and Swift for iOS. I started working with CreateJS as soon as it came out. Its JavaScript API was quite similar to the Flash platform's ActionScript 3 programming language. CreateJS was created mainly for Flash developers looking to switch to JavaScript. I've used it in many projects along the years and found it quite easy to use. I've also tutored students and found that even students with a very basic software development background can easily pick up the CreateJS concepts and master its API in no time. In this course, we are going to create a breakout-style game by using the CreateJS suite. We are going to control the visuals, input, and sounds using CreateJS, and basic JavaScript for the game logic itself. We are going to have 6 sections in this course. In the first section, we're going to have a short overview of CreateJS. In the second section, we're going to start working on the game stage itself. In section 3 and 4, we'll work on the game logic. In section 5, we're going to learn basic testing and debugging of JavaScript apps. And in section 6, we're going to wrap up the course. The course prerequisites are basic HTML and basic JavaScript. If you are familiar with both, then you are ready for this course. Enjoy! Hello and welcome to the first video of section 1 on CreateJS. In this section, we'll review CreateJS capabilities and we'll see how to load CreateJS library to a web page. In this video, we're going to discuss about the CreateJS suite. We'll start off by visiting the CreateJS website, www.createjs.com. This is how the CreateJS website looks as of June 2015. Let's do a quick overview of CreateJS. CreateJS is a suite of JavaScript libraries for creating interactive experiences with HTML5. The CreateJS APIs are quite similar to the ActionScript language, which is used in the Flash platform. Since Adobe is one of CreateJS's official sponsors, CreateJS has support in the Adobe Animate application, and so assets created in Adobe Animate can be easily exported to CreateJS. However, in this course, we'll learn how to use CreateJS without any third-party tools. Let's review the components of CreateJS. EaselJS library is for bitmap and vector drawing in the HTML5 canvas. TweenJS library is for tweening and animating HTML5 properties. SoundJS is for playing audio in HTML5. And last but not least, PreloadJS. PreloadJS is a JavaScript library which allows you to control and manage loading of assets. Now, in order to use CreateJS in a web page, you have 2 options. One is to visit the GitHub website by clicking the icon on the top right corner and downloading the library to our local computer. This is usually recommended for networks which don't have external internet access. Otherwise, it's best to use the second option, which is to use the CreateJS CDN link, which is listed in the installation section right here. The link is changed every time a new version is released. So don't worry, even if the CreateJS library will update, you'll still be using the same version you've started developing with. So now we can just copy the link and we'll move to the text editor to start implementing the library and start creating our first CreateJS app. Here we have the HTML template, which we will use. As you can see, we have the head and the body. And we will implement the link we just copied below the title tag, because we want the application to load this before loading anything else. In order to use CreateJS, we need to create the canvas object. The canvas object is placed in the body. We create a canvas object with the ID of test canvas. We'll use width 500 and height of 500. We'll open a script tag to start writing some JavaScript code. And here we'll create a new method called init. In this method, we'll create a circle using EaselJS, which I've mentioned earlier, and I will place it on the canvas. We need to make sure that the first thing that the application does is load this method. So what we'll do is place an onload event in the body tag, which calls the init method. In the script tag, we'll write function init, and we're going to create the circle. So first thing we're going to do is create a variable called stage. The variable called stage will need to reference the canvas object whose ID is testCanvas. So we're going to create the stage variable, new CreateJS.stage, and as a variable we'll use the name given to the canvas object testCanvas. Now we'll create a circle. The circle uses the shape object, so we're going to use CreateJS.shape. The drawing API of CreateJS allows you to draw objects on screen dynamically. So the circle object which we've just created is a shape object which we can access its graphics property and fill it with the color red, and use the drawCircle method which receives X property, Y property, and a diameter property. Now we're going to change the X and Y axis. And we're going to place it on the stage. Now we can check and see if the circle is actually on stage. So we're going to load the page and see that nothing is displayed on screen. Why isn't anything displayed here? This is due to the fact that for optimization purposes, the stage doesn't update the canvas in each and every frame, so the developer controls the update rate of the canvas. So let's get back to the code. Now, if we'll add stage.update at the end of our code and try again, then we can see that the circle appears on screen. Congratulations, you've just created your first CreateJS app. Now we're ready to move on to the next video, playing sounds in various browsers using SoundJS. Hello and welcome to video 1.3 of section 1 on CreateJS. In this video we're going to discuss about playing sounds in various browsers using SoundJS. We're going to start off by taking our HTML template and creating a new test file. In this test file we're going to do two things. One, we're going to load the sound we wish to play, and the second thing, we'll add a button, and once we click it, the sound will be played. So let's add the JavaScript code in the head section. We've added function load sound, which uses the register sound method of CreateJS and receives two parameters. The first one is the path. The file we wish to play is called hit.og and it's in the local assets folder. The second parameter is the ID. The ID is the name which you'll use to reference that sound afterwards when you try to play it. So now we move to the playSound function. Here we use the play method from CreateJS, CreateJS.sound.play, and the parameter it receives is the ID of the sound we wish to play, in our case, hit. Let's move to the body tag. Here we'll add a button element. The on-click event of that button will be playSound, which we created here. The text on the button will state play sound. And in order to make sure that CreateJS has loaded before we start doing anything, we'll use the onload event. And once the HTML page will be ready, it will start running the load sound method. Okay, so let's test it on Chrome. As you can hear, once I click the play sound button, the sound is played. If we'll switch to Microsoft Edge, you can see that once I click the play sound button, the sound isn't played. This is because Microsoft Edge doesn't support OGG files. So in order to work around this issue, there's a property in SoundJS which allows you to add alternate extensions for a specific file. For example, in our assets folder, I also have the hit.mp3 file. So I can use here the alternate extensions property from SoundJS to let the browser know that if he cannot play the main file, which is hit.ogg, he can try other extensions with the same file name and see if he can play these files. We'll write createjs.sound.alternate extensions. So now, once Microsoft Edge will try to play the hit.ogg file and not succeed, it will try to play the hit.mp3 file. Let's test it. Once Microsoft Edge will reload the page, and as you can hear, the play sound button now actually plays the sound. But in this case, it played the hit.mp3 file, unlike Chrome, which played the hit.ogg file. So always make sure that these are the same files and the same sound. Congratulations! Now you know how to play sounds using SoundJS. In the next video, we're gonna learn about tweening objects using TweenJS. Hello and welcome to the section 1 on CreateJS. In this video, we're gonna talk about tweening objects using TweenJS. We're gonna learn how to tween an object and test various types of tweening. We'll do this by using the circle we've created in video 2. If you recall, in video 2 we've created this circle. We're gonna start off by removing the stage update command. This is because TweenJS has its own way of refreshing the stage. Now we can use CreateJS's ticker class, which is used to set the frames per second you want to use in your app. So first of all, we're gonna set the frames per second to 60. CreateJS.ticker.setFPS, and we're gonna set it to 60. Next thing we're gonna do is we're gonna add an event listener, which is gonna listen to the tick event that the ticker class dispatches. Each time this event is dispatched, we're gonna update the stage. So we're gonna use createjs.ticker.addEventListener, and we're gonna add the tick event, and we're gonna set the target of this event listener to the stage. If we'll refresh the page, we'll see that the circle still appears even though we removed the staged update, meaning the ticker class is working fine. So we're gonna start off by adding a simple tween. We're gonna write createjs.tween.get, and now we're gonna name the object which we're gonna use the tween on. In this case, the circle. After this command, you're gonna need to add 2, which will be the endpoint of the tween. So we're going to do a simple tween, which is going to change the alpha property of the circle to 0. So we're gonna write 2, and we're gonna open curly brackets, and we're gonna list the property which we want to change, which is alpha, and list the endpoint as 0. We're gonna also add an additional parameter, which is the time in milliseconds, which represents the time CreateJS takes to perform this tween. So we're gonna write 3 seconds, which is 3000 milliseconds. Now, if we test the page again, you can see that the circle slowly disappears. Now, in addition to changing the alpha property, we'll also change the x property. So we're gonna add it to the curly brackets as an additional parameter. We're gonna list the endpoint of the x property to 400. If you recall, the start point was set by us to 250. So after the tween is over, the endpoint should be 400. Let's test it again. As you can see, the circle still disappears, but now it also moves on the x-axis. Another property which you can use in the tween command is the easing property. Easing property allows you to set different types of easing, which controls the intensity and speed of the animation. For example, we're going to test the elastic easing, and we're going to write createjs.ease.elasticin. If we'll refresh the page, we can see that the circle animation now has easing added to it. In the CreateJS website, you'll be able to see all the types of easing which you can use. Now we're going to add a new parameter to the get function. We're going to add the parameter loop in curly brackets, and we'll set it to true. When we add this parameter in the get function, the entire tween will loop indefinitely. Let's go back to the page and see its effect. As you can see, the animation loops over and over again. Every time it reaches the end of the tween, it starts over again from the previous start point and starts the animation and plays it until the end. The tween method is chainable, so you can add more and more to calls to it, and they'll be added to the tween. So for example, we have the original 2, which sets the alpha to 0 and the x value to 400. Now we're going to add a to call, which sets the alpha value to 1 and the x value to 100. We'll set the time to 1.5 seconds. Now, when we test the animation, you can see the animation contains the two calls which we've added to the tween. So as you can see, you can add more and more to calls, and they'll be added at the end of the previous to call. Now, for example, let's change the ease of the first to call to elastic in out and add it to the second tween as well. You can see that the animations now blend in smoothly. Congratulations, now you know how to tween objects using TweenJS. In the next video, we're gonna learn about loading graphic assets using PreloadJS. Hello and welcome to the section 1 on CreateJS. In this video, we're gonna learn how to load graphic assets using PreloadJS, calculate the loading percentage, and display the graphics. We're gonna start off as usual using our HTML5 template, which already contains the importing of the CreateJS library. In the body tag, we're gonna add an event for onload, which is going to call a function called init. In the init function, we're gonna add the entire functionality. We're gonna start off by creating a new variable called q. The q variable will be initiating using new createjs.loadQ. The loadQ element will assist us in creating a loading queue for loading the graphic assets. PreloadJS can be used to loading other elements, not just graphic assets. It can be used to load sounds, and it can be used to load files. So we're going to write varq new createjs.loadQ. Now we're going to write the init function. The loadQ object in CreateJS has a few events which we can listen to, and according to these events, know what the progress of the loading is. So we're going to add 3 of them. The first one is progress, which provides us with the exact percentage of loading of the entire queue. For example, if we have 2 elements, after the loading of the first element, we'll have 50% loading, and after the second element, which is also the final element, we'll have 100% loading. So we're going to write queue.on, open brackets, the name of the event is progress, and we're going to call a function called handleFileProgress, which we're going to write later. The second event which we're going to use is fileLoad. The fileLoad event is dispatched every time a file completes its loading process. What we're going to do in this event is display the image we just loaded. So we're going to write queue.on, open brackets, the name of the event is fileLoad, and now we're going to call a function called handleFileLoad. The third event which we're going to listen to is complete. The complete event is dispatched every time the loading process has completed, which means that all the files have been loaded. So we're going to write queue.on, the name of the event is complete, and the name of the function we're going to call is handleComplete. And we're going to write it later. Now what we need to do is load the files. The CreateJS library has a method called loadManifest. LoadManifest receives an array of file names and loads them one after the other. So in our case we have an assets folder which has 3 files, 1.jpg, 2.jpg and 3.png. And we want to load them in this order. So we're going to write queue.loadManifest, open brackets, and we're going to create a new object. The first variable is ID. That's the name which we'll use in the application to call that file after we've loaded it. The second parameter is source, spelled src, which contains the path to the file. Since we have it in our assets folder, we're going to write assets/1.jpg. We're going to do the same thing with the 2 other images. And we're going to close the brackets. Let's review what we've just done. We've added event listeners to the loading process, and we've listed the files we want to load in that loading process. Now we're going to write the functions which we used for the event listeners. So we're going to write function handleFileProgress. The parameter it receives is an event, and here we're going to use the console. We're going to write console.log. In order to get the progress, we're going to use the queue variable and access its progress property in order to know the progress. So this line will show in the console our progress. The second function which we're going to write is handleFileLoad. HandleFileLoad also receives an event as a parameter. In this case, we're going to take the file we just loaded and display it on the HTML page. So we're going to write var image, we're going to access the queue object, we're going to access its getResult method. Now one of the parameters of the event object, which we used in the header, is event.item.id. This property will give us the ID of the object we just loaded. So we used the myImage, myImage2 and myImage3 IDs. So these are the IDs which we're going to get at the end of each loading process. So now in the image variable, we have the image we just loaded. We're going to write document.body.appendChild, and we're going to add the image, and this will display the image on the HTML page. So now we have a handleFileLoad function, which is called every time a file has completed its loading process, and it displays the image we just loaded. The final function which we're going to create is handleComplete. In this function we're going to use the console again, and we're going to write loadingComplete in the console to state that the loading process has completed. Now it's time to test our code. We'll open the page in the browser, and open the console to see all the console calls we've added. So as you can see here, we see in the console the progress. We can see that the images are displayed one after the other in the page. You can see the percentage of the loading process of the images. And at the end of the loading process, we can see the loading complete call. Now we've seen the functionality of each one of the functions we've created. We've seen the handle file progress, which showed us the progress in the console. We've seen the handle file load function, displayed the image every time an image has completed its loading. And we've seen the handle complete function, which has written loading completed in the console. Congratulations, now you know how to load assets using PreloadJS. We have successfully completed the section of the CreateJS overview. In the next section, we're going to discuss about the game outline and how to start working on the game itself. Hello and welcome to video 2.1. In this section, we'll have an overview of the game. In this video, we're going to discuss about creating the graphic assets. We'll start off with our HTML template. We have the stage, which is defined as a variable, because we'll use it in several other functions, not just the init. So we place the variable outside the function, and we initiate the variable in the init function. What we wish to do now is create several constants which will hold the width and the height of the pedal and the bricks. So these are our constants. We have the pedal width, which is 100 pixels. We have the pedal height, which is 20 pixels. The bricks width, which is 60 pixels, and the bricks height, which is 30 pixels. In addition to the stage, we'll define two other variables. One of them is the pedal, and the other is the ball. The pedal and the ball will be the graphic assets of the pedal and the ball. Like in previous videos, we'll define the ticker at 60 frames per second. And we'll also define an event listener that each tick will update the stage, and this will save us calling the stage.update command in every frame. Next up, we want to create one ball, one pedal, and one brick for now. In the next videos, we'll create the brick wall, but for now we'll create only one brick. So let's define the first function. The first function will be createBrick. I'll paste the code and we'll discuss each command line by line. The createBrick function will define a variable called brick, which creates one CreateJS shape. We'll fill the shape with a specific color. You can define any color you want. We'll draw a rectangle, which starts off at the x and y axis of 0 and 0, and its width is the brick's width constant we've defined earlier, and its height is the brick's height constant which we defined earlier. We'll call endFill, which states that we completed the drawing of the shape, and we'll add object we just created, which is the brick, to the stage. Next, we'll create the ball. So the createBall function is very similar to the createBrick function, only this time we'll draw a circle. So we define the ball as a CreateJS shape, we fill it with a red color, and we draw a circle with a radius of 8 pixels. Its x value will be 100 and its y value will be 100. And we'll add it to the stage as well. Last but not least, we'll define the createPedal function. In the pedal function, we'll define the CreateJS shape inside the pedal variable. In this case, we're going to use the chaining ability in CreateJS. And as you can see, I can chain the draw rectangle to the beginFill command. So unlike the createBrick function, in which we created it in several lines, you can see that I'm chaining the commands here, and I'm basically creating the pedal using the beginFill, defining its color, drawing a rectangle in the location, width and height that I want, and then I place it on the stage. So now all we have to do is call these functions in the init function. So we'll use the create brick, and we'll use the create ball, and we'll use the create pedal. So now let's see the outcome. Now that I refresh the page, you can see that we've created one brick in the top left corner, one ball in the middle of the screen, and one pedal at the bottom of the screen. Congratulations! Now you know how to create graphic assets using CreateJS. In the next video, we're going to discuss about creating basic animations. Hello and welcome to video 2.2. In this video, we're going to discuss about creating basic animations in the game. In the previous video, we've created a basic layout of the stage, which looked like this. Now, we're going to focus on creating an animation for one of the elements. In this case, the element will be the brick. We wish to create a destruction animation for the brick, so that when the ball will hit the brick will have a destruction animation, which will play to give the player an illusion that the brick disappeared from the stage. So we'll create a new function called destroyBrick, which receives as a parameter a brick element, and we'll use TweenJS, which we've talked about in the previous video, and we'll change properties of the brick, the scale X and scale Y properties of the brick, to 0, giving the illusion that the brick is shrinking in size until it completely disappears. We'll set the time for this animation for half a second. So let's try to run this animation after we create the brick. Destroy brick, and we'll send as a variable the brick object we just created in this function. We'll save and we'll go to see the result. As you can see, the brick animation caused the brick to shrink in size until it completely disappeared. But there's only one problem here. The brick, as you can see, is shrinking towards the top left corner instead of shrinking into the middle of the brick. This can be easily fixed by changing the registration point of the brick to its center. The registration point states what the developer wishes the center of the object to be. So for example, the x-axis and the y-axis of the registration point by default is 0, 0. So always, by default, the top left corner of each object is the registration point. If we wish to change it to the middle of the brick, we need to change the registration point to its middle. Now, since we know its width, the middle will be half its width. And since we know its height, the middle, basically the y-axis of the middle, will be half of the brick's height. Now, since we change the registration point of the brick, that means that when we place it on stage, its middle will now be placed in the 0, in x-axis 0 and y-axis 0. So let's move the brick a bit so that we'll see all the brick, so that we'll see the entire brick. So let's move the brick to x50, y50. Let's see the output. As you can see, the brick is now shrinking towards its middle until it completely disappears, enhancing the effect of the disappearance. Congratulations! Now you know how to create basic animations in CreateJS. In the next video, we're going to talk about game stage creation and object positioning. Hello and welcome to video 2.3. In this video, we're going to discuss about game stage creation and object positioning. In the previous video, we've created basic elements. Now we're going to position them in the correct location on stage, and in the case of the brick, we're going to create a brick grid instead of just one. In order to create the brick grid, we'll need to modify the createBrick function we created in the previous video. We're going to add as parameters x and y, and instead of using hard-coded values like 50, we're gonna set the values according to the parameters provided by the function header. We'll remove the destroy brick call, because it was used as a demonstration in the previous video. And now we'll create brick grid function. I'll paste it and I'll explain what it does. The create brick grid function will run a nested loop. Nested loop means that a loop will run inside a loop in order to create the correct grid. Now, the I value will be in charge of the X values of the bricks, and the J value will be in charge of the Y values of the bricks. So the first loop will run 14 times, and the second loop will run 5 times. So that means we'll have 14 bricks in a row and 5 rows. In order to calculate the X value of each brick, we'll use the I value. We'll multiply it by the brick's width plus 10, which will be the space between each brick, which will be the 10 pixels will serve as space between each 2 bricks in a row, and we'll add 40 pixels to that, so that the first brick won't be too close to the left part of the screen. When discussing the Y values, we'll multiply the J variable to the brick's height plus 5. 5 pixels will be the space between each 2 bricks in a column, and we'll add 20 pixels so that the first brick will not be too close to the top. Now, instead of create brick, we're gonna call the create brick grid. And let's take a look at the result for now. As you can see, we have a brick grid placed on screen. But now the ball and the pedal are not in the correct location. So let's move them to the correct location. In addition to that, you can see that we cannot see all the bricks. We wanted to have 14 bricks in a row, but we have less. That's because the canvas is too small to fit all the bricks we've configured. So let's enlarge the canvas by going to the canvas definition here and setting the width to 1000. Let's take a look at the result. You can see we have all the bricks here. Now we just have to place the ball and the pedal in the correct location. So let's place the ball at the middle of the canvas. So in order to do that, we can state that we want to get the canvas width, and we divide it by 2, so we get the exact center of the canvas in the x-axis. If we do the same for the canvas height and divide it by 2, we get the exact middle on the y-axis. If we take a look at the result, we can see that the ball is exactly in the middle of the canvas. Now let's set the pedal location. The pedal x will be the width divided by 2. Now, since the pedal doesn't have a registration point, like we defined in the brick earlier, we'll need to remove the pedal width divided by 2 in order for it to be in the exact middle. The y-axis will be configured at 90% of the height of the canvas. This will leave some space at the bottom of the canvas for the ball to fall. So now we have the complete stage of the breakout game. Congratulations! Now you know how to create the game stage and position the various objects along the screen. In this section, we've learned how to create the basic game assets in order to be able to create the game stage before we start working on the actual game logic. In the next section, we're going to discuss about the game logic. Hello and welcome to section 3, Game Logic Part 1. In this section, we're going to discuss the basics of creating the game logic of the breakout game. Welcome to video 3.1, Game Logic Overview. A breakout game is a pretty simple game. The player is able to move using the mouse or the keyboard, the paddle at the bottom. The idea is to get the ball to hit all the bricks in the top third of the screen. Once all the bricks are gone, player levels up or the game is over, whichever you choose. If the ball falls beneath the pedal and basically exits the screen from the bottom, the player loses a life. So for example, here I can play for a couple of seconds and we can see that whenever I hit the brick is gone. And if I miss the ball, I lose a life. I started out with 3 lives, now I have 2 lives. And since I've hit 7 bricks and I'm getting 100 points for each brick I hit, I have 700 points. Now in this section, we're going to discuss about the logic of how the ball basically moves around the screen. And we're basically going to create a game similar to the one I just showed you. Congratulations! Now you know the game logic which we need to implement in the game itself. In the next video, we're going to actually add the code required to making this game work. Hello and welcome to video 3.2, adding the basic game logic. In this video, we're going to talk about how to implement the game logic into the existing stage which we've created in a previous section. If you recall, this is the way the stage looked in the previous section. We've added the bricks, we've added the ball, and we've added the pedal. Now, we wish to add the game logic into the game so that when the ball hits a brick, it will disappear, and so on and so forth. So let's take a look at the code. This is the code from the previous section. Now, we're gonna add the required changes to make the logic work. So first of all, let's do some cleanup. In the previous section, we've created ball in a constant radius here. We've added the value 8. Since we're gonna need the ball radius for various calculations in order to determine the location of where the ball hit, we're gonna add it as a constant. So we're gonna create a constant here. Call it ball radius, and we're gonna add the value 8. And we'll add it instead of the existing value 8. Next up, we've created the bricks variable, which is supposed to be an array. The array will hold all the bricks which are currently on stage. This way, when we test the location of the ball, in comparison to the location of the bricks, we'll be able to loop over the bricks inside the array and find out where the ball hit exactly. So we're gonna initiate the bricks variable as an array. Let's take a look at the init function. We've configured it to have 60 frames per second, which means that there are 60 ticks per second in this command. Now, instead of using the stage as the source of these ticks, we're gonna add a custom method, which we'll call tick, and we'll be able to determine what happens every time the ticker ticks. So instead of using the stage, we're gonna add a custom function called tick. We're gonna add it here. In the previous configuration, when we had the ticks go to the stage would update every time it would get a tick. But now, since we're using a custom method, we need to do it manually. So we're going to call the stage update method, which is required because otherwise the stage itself wouldn't update. The changes themselves would happen behind the scenes, but we wouldn't be able to see it visually on screen. Now we have some configurations we need to change in the ball itself. In the previous section, we've created a ball, we've added it visually to the stage, but now there are custom values we need to add to the ball object in order to be able to use them when we test the logic and the physics in the next sections. So we're going to add a few things here. I've added 6 attributes. The attribute up will be used to determine whether the ball is going up or down. This will help us determine if the y speed, which is always a positive value, is supposed to go up the stage or down the stage. We added the custom value right, which will determine if the ball is going right. If it's false, then it's going left. And the same goes for the x speed. Since the x speed is always a positive value, we'll know according to the custom value right if it's supposed to go right or left. Now the last two values, last x and last y, will save the previous location of the ball. This will help us in finding out where exactly the ball hit, because whenever we'll detect that a ball hit a brick, we'll need to know what was the previous location to know where exactly the brick was hit. I'll explain more later. Now in the createBrick function, which we've created in the previous section, we've basically added all the bricks to the stage, and without having any references to them. But now, since we're using the game logic, we need to know exactly where each brick is placed and when a ball hit that brick. So since we've created the bricks variable as an array, we're gonna add each brick we create to that array. So basically we're gonna push that object into the bricks array. So now we return to the tick function which we've created. And since we have the custom variables in the ball, we can start working with them. So I'm gonna test if ball is going up, then the ball y value will have the ball y speed value removed from it each tick. Because the y-axis basically starts from 0 at the top and goes down to higher values if the ball is going up. So basically we're removing a positive value from the y value of the ball to create the illusion of it going up. Now for the time being we'll do the same for the x value. We remove the same y speed value, which is currently 1, from the x value. This way we'll get a temporary movement so that we'll be able to see that the logic is working. And in the next sections we'll do specific logic for the x value. Now we're going to create a new function called checkCollision. The checkCollision will check if a certain element, in this case the ball, hit another element, in this case the brick or the paddle. Now we're going to add the checkCollision function. The checkCollision function works with the ball element and the brick element. In future sections we'll add it as a more general hit element because we'll add it to the paddle as well. And as you can see, in order to see if the ball element and the brick element actually collided, we're going to have various if statements. Now, if one of these statements occurs, then basically there was no collision. Otherwise, a collision had happened. Now we can check every logic we have here, and we're going to discuss it, and we'll see why that specific statement, if it occurs, it means that the ball hasn't collided with the brick. Now, the ball element, the x and the y values are exactly in the middle of the ball. So in order to get the borders of the ball, we need to add the ball radius. So if the ball x value plus radius is smaller than the brick element x value minus half the brick's width, it means that the ball itself hasn't hit the left part of the brick, because the brick element x is exactly in the middle. Half of its width brings us to the left part of the brick. So if the ball's right part hasn't hit the brick's left part, it means that there was no collision in the left part of that brick. Now the next statement, if the ball element minus the ball radius hasn't hit the brick in the brick element x value plus brick's width divided by 2, means that the ball hasn't hit the right part of the brick. If the ball element y value minus the ball radius, which brings us to the top part of the ball, hasn't hit the brick element y value plus brick's height divided by 2 means that it hasn't hit the bottom part of the brick. So the top part of the ball hasn't hit the bottom part of the brick. And the last statement, if ball element y plus the ball radius hasn't hit the brick element y minus brick's height, means that the bottom part of the ball hasn't hit the top part of the brick. So as you can see, what we're checking here is to see that the ball itself isn't anywhere inside the rectangle of the brick. So now that we have that logic, we'll be able to go back to the tick function and check every brick in the bricks array to see if it collided with the ball. So we're going to add a for loop, and we're going to check it from 0 to bricks length, which will include all the bricks, and check if check collision occurs between the ball and bricks in location I, so that we'll be able to check it with the loop. Then we're gonna run the destroy brick method, which we've created in the previous section. So that's it. We've added the code. Now we'll be able to see the basic logic, which is supposed to show us that the ball is going up, and while hitting the bricks, it basically destroys them. As you can see, every time that the ball hit the brick, it disappears. Now, since we don't have any physics, the ball is just going up and doesn't have anything happening to its velocity or direction once it hit the brick, but we'll discuss it in the next section where we talk about the physics engine. Congratulations, now you've added the basic game logic to the game. In the next video, we're going to talk about the game physics, which will give the game a more natural look. Hello and welcome to video of adding the game physics. We're going to look into the physics logic required for this game, and we're going to implement the physics logic on the ball, bricks, and paddle. In the previous section, we've created this demo. As you can see, the ball has an x speed and y speed, and it goes through the bricks without any return logic, without any physics logic. So in this section, we're going to add the physics logic, which is going to give the game a more natural look. If a ball hits the brick, it goes back. So let's take a look at the code. Now, first thing we're going to do is, if you recall, in the previous section, we just added y speed to the x value and reduced it from the x value every time. Now, this was for demo purposes. Now we're going to add a more natural movement, which means that if the ball is going up, then we're going to handle the y values only. The y speed is reduced from the ball y value in each tick. Otherwise, if the ball is going down, then we're going to add the y speed to the y value. Because, as I've stated in the previous section, y values go from 0 to in this case, 700, and while 0 is the top of the screen, 700 is the bottom of the screen. So if it's going up, we need to reduce the y value from the ball, basically remove the y speed values in each tick. And if it's going down, we're going to add the y speed to the y value. Now, since we have ball right variable, which lets us know if the ball is going right or left. So if the ball is going right, we're going to add the x speed value in each tick to the x value of the ball. Otherwise, if the ball is going left, we're going to remove the x speed value in each tick. So if the x speed is, for example, 5 pixels, then if the ball is going right, it's going to add 5 pixels each time to the x value of the ball, giving the illusion that it's going right. If x speed is 5 and the ball is going left, then we're going to remove 5 pixels in each tick, which means 60 times per second, from the x value of the ball, giving it the illusion that it's going left. Now, in the previous section, we've added the check collision function, which checks if the ball hits the brick, and if it does, then it destroys the brick. If we take a look at the destroy brick function, what it does is run an animation which shows the disappearance of the brick. But the brick itself doesn't disappear from the screen, it still resides in the screen, and it still exists in the bricks array, which means that even though we've hit the brick, and even though the brick shouldn't be on screen, it will still run through the loop of the bricks which are tested for collision. So in order to fix this problem, what we need to do is check if the ball hit that brick and that brick is destroyed, then we need to remove it from the bricks array by using splice. The splice function in JavaScript can be used on an array, letting him know which location in the array you want to remove and how many elements you want to remove from that location on. So in our case, since we found out that the ball hit bricks at location Y, we want to remove that brick from that array. Once it's removed, then we no longer need to worry that the bricks loop will test that brick. Now, since we remove a certain element from the array, then the next element will go back to that location. So we need to do a little fix, which we'll add by adding I minus minus. Because just to give you a sense of what's going on, let's say we have these 3 bricks and our current I value is 1, which means that x2 is the brick currently being hit. Once we remove it, the I value is still 1, and since we're going over the iteration inside the loop, then the I will become 2 and will no longer test the x3 value. So in order to fix that, reduce 1 from the I value. So basically, if we tested location number 1, after we splice a brick, we'll test location number 1 again, because it has a new value inside of it now. Now another thing we need to test, apart from the collision with the bricks and with the paddle itself, we need to test if the ball hit the wall in a certain location. So I'm going to paste the relevant code. So as you can see, here we have the various tests. If ball x plus ball radius is larger than the width of the stage, means that the ball hit the right side of the screen. So first of all, what we do is fix the location. Since the ball speed is dynamic, we may reach a situation that due to the fact that in each tick we add 6 pixels or 7 pixels to the x value, we may reach a situation that the ball itself passes by a few pixels the entire width of the stage. So for example, the entire width of the stage is 1000, but the x location is 1003 and 1004, which causes the ball to look as if it leaves the stage. And we want to give the user the illusion that the stage is closed and the ball just hit the wall and is going back. So in order to give that illusion, we need to fix the location of the ball so it wouldn't appear outside the stage. So we're going to take the ball x and we're going to add the stage canvas width minus the ball radius, which is the exact location of the ball had it hit the wall exactly. And since we hit the wall on the right side, the ball should change its direction to the left. So ball right is now false. If the ball x minus ball radius is smaller than 0, meaning that the ball hit the left wall, we need to fix the location like we did before, and then we're going to set the direction of the ball to the right side. So ball right equals true. Same goes for the top and the bottom. If the ball hit the top border of the screen, then we're going to change the direction of the ball to down. Basically, ball up equals false. And last but not least, if we hit the bottom of the screen, the ball should go up. Now this last if statement will be changed in a future section, because if the ball hits the bottom of the screen, then we lose a life. So it won't bounce back, it will reset the game. So we'll leave it temporarily here. Now, last but not least, in this section what we need to do is, after we test everything, we need to set the ball last x value to the ball current x value, and the ball left y value to the ball y value. If you recall, in the previous section we've created these custom variables, last x and last y, for the ball. This will be used to determine what was the last location of the ball before it reached its current location. This will be able to determine where the ball hit exactly. We'll use it in the next function, which is check-collision, and we'll see exactly what happens there. Now, in the previous section we've added this basic logic to the collision, which checks if the ball itself is outside the perimeter of the rectangle which surrounds the brick element, then we can determine that they haven't collided. Now we need to add a more complex logic to it, so we're going to change it a bit. I'm going to paste some code and we're going to discuss it. Now, the code that I pasted, although it looks scary, it isn't so scary. It's supposed to make the reading of the physics code much easier, given that we have a name for each one of the borders. So I've created a left border, a right border, top border, and bottom border variables for the hit element. The hit element will replace the brick element, which we used in the last section, because check collision function more general, since we're going to use it on the paddle as well. So left border basically takes the x value, takes the width of the element, and divides it by 2. This way we'll get the left border. The right border, same thing, we take the x value and we add half the width of the hit element, and we get the right border. Top border, bottom border, same thing. Now we have the previous ball left border, previous ball right border, previous ball top border and bottom border, and the current ball left border, right border, top border, and bottom border. Now the main logic we need to add here is similar to the one that we had in the previous section. So if we create a similar logic, we have this, which means if the ball left border is smaller or equals to the right border, and the ball right border is larger than the hit element left border, and the ball top border is smaller or equal to the bottom border, and the ball bottom border is larger or equals the top border, once all these statements are true, then the ball is inside the rectangle of the hit element. So we're going to return true here, and we're going to return false here. So if all these statements are true, then it means that the ball element and the hit element have collided. Otherwise, they haven't collided. So we've recreated the logic from the previous section with our current variables. Now we're going to add some new logic, which is supposed to determine where exactly the ball hit. This is important to us so that we'll know how the return angle should be. For example, if we hit the hit element at the bottom, the y speed should reverse. So if the ball was going up, hit the hit element at the bottom, the ball is supposed to go down. If the ball hit the hit element on the right side, it means that it was going right. It hit it on the right side, and now it's supposed to go left. These basic tests should cover all sides of the hit element. So even if we hit the top right corner, the logic from hitting the top and the logic from hitting the right should both work, and then the ball will go up and right while it was going down and left when it was hitting it. So let me just paste the logic here and we'll discuss what exactly is happening. I've added this code, which I've marked here. As you can see, what I'm doing here is testing each one of the statements which appears in the if statement above, while testing the previous location of the ball. So for example, if the ball top border is smaller or equal to the bottom border, it means that the ball's top part is inside the rectangle's bottom part. Now we want to test the previous location. If the previous ball top border was larger than the bottom border, it means that in its previous location, it wasn't inside the bottom part of the rectangle. So that means that currently, in the current tick, the ball hit the bottom part of the hit element. So if that's the case, then the ball element should go down. So ball element.up equals false. Now again, like we did in all the previous collisions, we need to fix the location of the ball so that it wouldn't appear as if the ball entered the hit element. In order to give the movement a more natural look, we cannot let the ball or any other part overlap another element. So if we reach the position in which the ball overlaps the hit element, we need to fix it immediately to give it a more natural look. So the same thing here. If the ball bottom border is larger or equal to the top border, it means that currently it's in the top of the hit element. If the previous ball bottom border was smaller than the top border, it means that previously, in the previous tick, it wasn't there. So it means that in the current tick, the ball element hit the top of the hit element. So ball element.up equals true, and the same goes for the right side and the left side of the hit element. After we do that, then we update the last x and last y of the ball element so that the logic above will not reiterate in the next tick. Basically did all the required fixes. We moved the x and the y in order to avoid any overlapping, and now we need to update the last x and last y so that this logic would not reiterate in the next tick. Now we need to do a few fixes to the paddle. In order to add collision to the paddle, we need to add the same logic we did to the bricks. First of all, we need to add the registration point to the paddle so that x0 and y0 values of the paddle will be the exact middle of the paddle. So we're going to add the paddle registration x as half the width of a paddle and registration y as half the height of the paddle. We've added the getBounds function here. As you can see, we're testing it in the check collision. Now when you test a general element and ask for the getBounds function, it's supposed to give us the rectangle of that hit element. Now this rectangle is not part of the CreateJS framework. We need to add it manually. Every time we want to test the bounds of a certain element by using the getBounds, we need to make sure that we set it beforehand when we created that element. So we're going to set bounds of the paddle. We're setting the middle point, which is the paddle registration x and paddle registration y. And then we set the width, which is the paddle width, and the height, which is the paddle height. Now by using the set bounds, we'll be able to use the getBounds in the future and get the values like the width and the height. We're going to do the same to the brick itself. So we're going to set its bounds and brick registration x, brick registration y, brick's width, brick's height. Now, when hitting the paddle, the return angle of the ball should be determined according to the location on the paddle in which the ball hit. Because unlike hitting a brick, let's say we hit the brick at the bottom, so the y direction should be reversed. And if we hit the brick on the right, then the x direction should be reversed. In the paddle, the return angle should be determined according to the location on the paddle in which it was hit. Let's say the ball hit exactly in the middle of the paddle. The x speed should be minimal because it's the exact middle. So can't return to the right or to the left. We hit the middle, so we're just going up. So the y speed is the main element here. But if we hit the paddle in the right or in the left, then it should return according to the location it was hit in the paddle. So we're going to add a new function called new ball x speed after collision. Here we're going to get two variables, ball element and hit element, And we're going to set a few variables, which are the start point, the midpoint, and the end point of the hit element. The hit element in its specific use will be the paddle. So we're going to test if the ball element hit on the left of the midpoint, then the ball should continue to the left. So the ball right value is false, and the ball x speed should be determined according to the location in which it hit. So we're going to add a new variable called full speed x. And we're going to test. Now if you take a look at the x speed, we're going to take the 7, which is the absolute value, and we're going to take a percentage off according to the location where the ball hit. So if the ball hit closer to the middle, then this equation will be equal 1 or closer to 1. And then 1 multiplied by full speed will give us full speed, and then full speed minus full speed will be 0. So this equation gives us the percentage of the speed which we'll have after the ball hit. So this is once we hit the left part, and this is once we hit the right part of the paddle, which we have a similar logic. We take the full speed and then check the endpoint according to the middle point to get the exact percentage that we need to add it to the full speed. Now, last but not least, we need to remove the brick itself from the screen after we completed the animation. So we're going to add a new function called remove brick from screen, and we're going to get the brick as a variable, and we're going to use the stage remove child to remove the brick. Now, since the animation of destroying the brick is 500 milliseconds, we're going to set a timeout for removing the brick from the screen for 500 milliseconds, and we're going to send the brick, which we just removed, as a variable. Last but not least, we're going to change the x speed and the y speed to default values of 5. Now we can test the new game. As you can see, the return the ball returns according to the hit in the brick, but we still can't see the ball hitting the paddle itself. Now why is that? It's because we haven't added the collision test to the paddle itself. If we go to the tick function, after we've destroyed the brick and we've checked everything, we need to check the collision of the ball and the paddle. If the ball and the paddle collided, then we can change the ball speed using the function we've created earlier. So let's take a look at the game again. As you can see, now when it hits the paddle, it reacts exactly like we coded it to be, meaning that we have a new x speed according to the location where it hit the paddle, and as you can see, the physics is very accurate. We don't see any elements overlapping. We see whenever the ball hits something, it returns to the natural direction it should go to, and basically the game runs perfectly. Congratulations! Now your game has a physics engine. In the next video, we're gonna add the scoring system. Creating the scoring system, we're gonna create a text field on the stage which will represent the score and the remaining number of lives. We're gonna add the scoring logic, and we're gonna add the lives logic. Now, if you recall in the previous section, this was the way our game looked. As you can see, when the ball reaches the bottom, we don't lose any lives, and it just continues bouncing. On the other hand, when we actually hit a brick, we don't see any score added to our score, and we don't see anything basically. We don't have any visual representation of either the lives or the score we currently have. So that's what we're going to add now. First of all, we're going to add 3 new variables. One of them will be the score, which at the beginning should be 0. The other should be lives, which at the beginning will be 3. And the third will be score text. The score text will be the visual representation of the score and the lives. It will be a text field which we'll create in CreateJS, which will have this info. So first we're going to add a new function called add_to_score. This function will get points as a variable and will add these points to the score. After adding it to the score, we will add to the score text the new data. So we're going to display score equals the score value slash lives and the lives value. Before we can edit the text of the score text, we need to display it on stage. So we're going to add a new function called createScoreText, which basically creates the text field element on the stage. So we're going to add new CreateJS text, and the default text will be empty. The font type will be 16 pixels in height, and we'll use Arial, and its color should be black, so we'll use the HTML code for black. Its location should be at the bottom of the stage. So we're going to take the canvas height and we're going to remove 16 pixels because the height of the text field, as you can see above, is 16 pixels. So it will be really aligned with the bottom of the stage, and we're going to add it to the stage. Add child and score text. Now the last thing we should add is the loseLife function. LoseLife function will reduce 1 from the number of available lives. The score text will again be updated, so we can use the same text we have here. Now, after we lose a life, usually the ball returns to the paddle and sticks to the paddle until the user clicks and the game restarts. We're going to elaborate about this in the next section when we talk about the mouse interaction and the keyboard interaction. But for the time being, what we're going to do is when we lose a life, we're going to set the ball X speed and ball's Y speed to 0 so that the ball won't move after we place it on the paddle. So the ball X is the paddle X, and the ball Y should be the paddle Y, which is the middle of the paddle, minus half of the paddle height, minus the ball radius. So this way we're going to place it exactly on the middle of the paddle. Now we need to add the add_to_score function and the loseLife function in the correct locations. So in the previous section, we've added the destroy brick logic. Now, whenever we destroy a brick, basically hit it. So we can add to score 100. Now, if you recall in the previous video, I told you about the fact that currently the ball bounces when it reaches the bottom of the screen. But in fact, the user should lose a life once it reaches the bottom of the screen. So we're going to take this logic and change it to loseLife. Now we need to add the text to the stage, createScoreText, and we'll add it in the init function so that we'll have it on screen. Edit the previous section and show the fact that it's a function. Now we're going to test the game. As you can see, we've hit one brick and the ball left the stage at the bottom. We lost one life. I'll refresh and then you can see that it happens again and again and again. Now one thing we can see that the text doesn't appear before we hit one brick. So let's see what we can do in order to fix this issue. After we create the score text, let's use the add to score method which we've created earlier and set it to 0. So we add 0 points to the score, but in this function we'll also display the new text. So now that we test the game, we're going to see that the text appears from the beginning of the game. And the score is updated and the lives are updated. Now since the pedal doesn't move, because we don't have any mouse or keyboard interaction, then in the next section we'll be able to see how it progresses with hitting more bricks and losing more lives. Congratulations! Now you know how to create a scoring system in your HTML5 game. This concludes our Game Logic Part 1 section. In the next section, we'll add the final touches to the game logic and complete our game. Hello and welcome to Section 4, Game Logic Part 2. In the previous section, we've mainly focused on the game stage and basic physics of the game. In this section, we'll focus more on the user interaction. Welcome to Video 4.1, Add Mouse Controls. In this video, we're gonna discuss about capturing the mouse movement events, moving the pedal according to the mouse location, and limiting the pedal movement in case the cursor goes outside of the stage. If you recall, in the previous section, we've added the physics engine and we've created the stage with the bricks above and the pedal below and the ball in the middle. Now, what we want to do is add some interaction to the game, so that the player will be able to move the pedal, so that he'll be able to catch the ball and avoid dropping it below the stage. So this is the game in our current state. Every time the game starts, the ball starts moving automatically, and we don't have any interaction with the game itself. In order to make the game more user-friendly, what we're gonna do is we're gonna stop the ball at the beginning and listen to mouse events. Once the user will click the stage, we'll start moving the ball. This way, the player will be able to let the game know when he's ready to start playing the game, instead of the game starting automatically. So in order to do that, we're going to add a Boolean variable called GameStarted, which we'll use to let the game know whether it's in a pause state or it's in a game state. In a pause state, the ball will follow the pedal and will stay on its surface. In the game state, the physics engine and everything we've worked in the previous sections will come into play. Now that we have a Boolean variable called GameStarted, which is set to false at the beginning of the game, we need to add an action which will change it to true so that the game will be able to start. So this action will be a click on the stage. So we're going to add an event listener for mouse down on the stage. So we're going to write stage on. We're going to listen to the event stage mouse down, and we'll add a function. Now, in order to avoid a situation in which the player clicks during the game, which will cause the game to restart over and over again, we'll check upon clicking the stage if we're in a state of game started equals false. So if game started is false, then we're going to change it to true. We're going to change the ball speed to 5 and the y speed to 5 as well, which were the initial values in the previous sections. We're going to change the ball up to true, meaning that the ball is supposed to go up, and the ball right to true, meaning that the ball will go right. So once the user will click the mouse, when the game is in pause state, the ball will start moving up and right using the X speed and Y speed values. Now, in order to make the ball stay on the pedal until we click the stage, we'll need to go to the Create Ball section and change the initial values. So the initial X won't be the middle of the stage, it will be the middle of the pedal. And the initial Y won't be in the middle of the stage. It will be the pedal surface, which is the pedal Y minus the pedal height divided by 2 minus the ball radius. And the initial speed should be 0, because we want the user to click before the ball actually starts moving. Next, we go to the loseLife function, which we've created in the previous section, and we're going to make sure that once the user loses a life, the game switches to pause state again. We'll go to the tick function, and we're going to make sure that none of the physics engine logic will work in case the game is in pause state. So we'll check. If the game started value is false, then ball X should be the pedal X, and the ball Y should be the surface of the pedal. This way, when the user will move the mouse, he will move the pedal and the ball will move along with it. I'm going to call the stage update so that the canvas will update. And we're going to add return because we don't want any of the logic which is below this section to run in case the game is in pause state. Now, if we take a look again at the create ball function, we can see that since we are basing the location of the ball on the location of the pedal, we have to create the pedal before we create the ball. So let's go to the init function and move the create ball command to after the create pedal command. Next, what we're going to do is make the pedal follow the mouse. So we're going to do that by adding pedal X equals stage mouse X. Now let's check the game. As you can see, the pedal follows the mouse, and once I click the stage, the ball starts moving. Now if you notice, the pedal also leaves the stage. I can make the pedal leave the stage on the right, and make the pedal leave the stage on the left. So we're going to add a few boundaries to make it look more natural and not as if the pedal moves through walls. So I'm going to copy paste now a part which will serve as the logic of not moving through walls. Here we can see that if the middle of the pedal plus half of the pedal width passes the width of the stage, then we move it back so that its location will be exactly the end of the stage. Same goes for the left part. If the pedal X minus half the pedal width is smaller than 0, it means that we passed the stage on the left, and we need to move it back so that the entire pedal will be inside the stage. Now, once we have this logic, if we take a look at the game, I can no longer pass through walls. Once I click the stage, I can start playing. Congratulations! Now you've added mouse controls to the game. In the next video, we're going to add keyboard controls. Hello and welcome to video 4.2. In this video, we're going to add keyboard controls. We're going to take a look at capturing keyboard click events, adding actions to specific keyboard click events, and avoiding cases in which the mouse cursor location overrides keyboard events. In the previous video, we've added mouse controls to the game. Now we want to add similar controls using the keyboard, so that the game will be playable by mouse or by keyboard. Unlike mouse events, which are based on the location of the mouse cursor, keyboard events work differently. the stage listens to keyboard events and gets a key code for the key pressed. What we need to do is listen to specific key codes which we need for the movement of the pedal. So we need the key code for the left arrow, the key code for the right arrow, and the space bar. Now these values are: key code left is 37, key code right is 39, and the spacebar is 32. Now keyboard events start when a key is pressed and are also called when a key is let go. So in order to know if the pedal needs to move left or needs to move right, or if a key is being pressed or a key was just released, then we're going to use Boolean variables which will let us know the direction of the pedal. We'll have keyboard move left equals false and keyboard move right equals false. When the user will click the right arrow, we'll change it to true. When the user will leave the right arrow, we'll change it to false. Same goes for the keyboard move left. When the user will click the left arrow, we'll change it to true, and when the user will leave the left arrow, we'll change it to false. Now we need to add the handlers for the key down and key up events. So we're going to add the handlers. Right window on key up, we'll have the key up handler, which we'll create soon. And the window on key down, we'll have the key down handler, which again we'll create soon. The key down handler receives as a parameter an event, which one of its internal variables is the key code. The key code of the key that was just clicked. So we're going to use a case switch. We're going to check if the key clicked is key code left, then the keyboard move left will be true. If the key which was clicked is the right arrow, then keyboard move right will be changed to true. If the spacebar has been clicked, then we're going to call the start level function, which we'll create soon. We'll end each of these cases with a break. And that's it for the key down handler. Now, the key up handler receives an event which has the key code parameter, which lets us know which key was just released. So, if the key code left is received, then it means the user let go of the left arrow, then keyboard move left equals false. If the user just let go of the right arrow, then keyboard move right equals false. That's it for the key up handler. So in summary, we have a key down handler which listens for left, right, and spacebar, and the key up handler which listens to the left and right arrows. Once we click the spacebar, we need to call the start level function. Start level function will do something similar to what the click on stage function did in the previous video. So we're going to create a start level function, and we'll basically take everything we created in the previous video in the stage mouse down and add it to a function. This way the mouse events and the keyboard events will be able to use it. Now we have a small problem. Now that we have keyboard events alongside the mouse events, sometimes they overlap. So for example, even though I click the left arrow on the keyboard or the right arrow on the keyboard, I still have the logic that the location of the paddle is supposed to be the location of the mouse cursor. So that means that even though I click on the left arrow, the paddle will always return to the location of the mouse. So we need to handle this situation. So what we're going to do is, instead of using this command here, meaning in each frame change the location of the paddle according to the location of the mouse, we're going to take this command and we're going to call it only if the mouse actually moved. So we're going to use stage on. We're going to listen to the event stage mouse move, and we're going to create a function which will include the command we just removed from the tick function. So what this means, that only if the mouse was actually moved do we need to move the paddle according to the mouse. Otherwise, the keyboard events can still work. So the user is able to start playing the game with the mouse, and then switch to keyboard, and then switch to mouse, and back and forth. Now the last thing we need is handle the movement of the paddle using the keyboard. Go to the tick function, and we're going to state here, if keyboard move left variable equals true, then we want the X of the paddle to move 5 pixels to the left. If the keyboard move right variable equals true, then we want the paddle to move 5 pixels to the right. Now let's test the game. This time I'll play only by keyboard. As you can see, I'm not moving the mouse cursor. I'm clicking only on the right and left arrows. When I'll click the spacebar, the game will start. Once again, click the spacebar and the game will start again. If you find the game difficult when using the keyboard, then maybe you can change the speed of the paddle. Instead of moving 5 pixels, we can move it 10 pixels. Congratulations! Now you've added keyboard events to the game. In the next video, we'll discuss mobile support. Hello and welcome to video 4.3. In this video, we're going to talk about mobile support. While in the previous videos, we've focused more on desktop computers while we attached keyboard events and mouse events to the game, we're going to take a look at adding touch events to the game and changing the stage to fit various devices. Now, CreateJS is pretty self-sufficient in terms of touch events. Once you enable touch events in CreateJS, it automatically converts all the mouse events to touch events. So what we've created in the Add Mouse Support section will work here once we enable touch events. How do we enable touch events? We go to the code, and after we create the stage itself, we're going to call the createjs.touch.enable, and this receives as a parameter the stage itself. So now we've enabled touch events in the stage. So all the logic of the paddle following the mouse X location works here with touch events automatically once we use this command. If we switch to mobile view, we can see that once I click the screen and move the finger across the screen, the paddle moves according to the location of the finger. Now this is great as long as we're on the stage, but if I move the finger location outside of the screen, as you can see, the paddle isn't moving. Now, unlike mouse cursors, which can be placed on top of the stage without interfering with the game, if you place your finger on the stage, you probably won't see the pedal because your hand will cover it. In order to make the game more user-friendly for touch devices, we're going to enlarge the stage so that even the section beneath the status text will be part of the canvas. So in the init function, we're going to add stage, canvas, height, and it will check the inner height of the browser screen, and according to that, enlarge the canvas. If we'll test it again, you'll be able to see that even though the finger is below the paddle and the game stage, you can see that even though I place the finger below the original stage location, I can still move the paddle and I can still click to start the game. Now, since the stage is now larger, the ball has a larger gap to fall into once the game is over, but it's a nice side effect. Congratulations, now you've added mobile support to the game. In the next video, we're going to discuss web storage and how to save the game data. Hello and welcome to video 4.4. In this video, we're going to talk about the web storage and how to save game data into the web storage. In the previous video, we've talked about adding touch events to the game. Now, we're going to focus more on the data side of the game and how to handle it. One of the elements to make a game more competitive is to add a high score. You'll be able to see if you improve through time by seeing every time you play the high score you received. Now, if we use a standard variable every time we refresh the game, the variable will reset. So in this case, we'll use the web storage. Web storage consists of local storage and session storage. Session storage is relevant only for this current session, meaning that if we refresh the game, the variables will reset. So it's of no use to us. So we'll use the local storage to save data in between sessions. So even though the user refreshes the browser, the data will still be there. So we're going to add the high score variable, which we'll use to hold the value which is available in the local storage during the game. So first of all, web storage isn't available in all browsers. So we'll add a small test to see if this browser actually supports it or not. If type of storage is not undefined, it means that we have local storage available. Otherwise, we don't. So if we don't have local storage available, then we'll just reset the high score. If we do have local storage available, we'll check the local storage and see if we have the high score variable. If we don't, then we'll initiate it with the 0 value and we'll take the value in the local storage and we'll place it in the high score variable we created earlier. So in summary, we check if the high score variable exists in the local storage. If it doesn't, place 0. If it does, then we just add the value to the local high score variable. Now, if you recall, in the previous videos, we created the status line. The status line here states the score and the number of lives remaining. We want to add the high score as well. So in order to do that, we'll create a function called updateStatusLine, which will be the only function that handles these kind of updates. This way, we won't need to add it manually to each section, like in the highlighted command. So we're going to take this command, and we're going to add high score. And then we'll call this function every time we wanted to update the score text. Now, one thing we didn't handle in the previous videos is what happens when the lives value equals 0, meaning that the game is actually over. So what we're going to do in this case is if the lives value equals 0, then we'll end the game. A new game will restart with a new number of lives, and the score will reset. But at that point, we'll be able to check the score to see if we've reached a high score, and then update the local storage accordingly. So this will be done in the loseLife function. We're going to test if lives equals 0, then if the high score value which we have stored is smaller than the current score value of the user, then the new high score will be the current score, and the local storage high score will also be the current score. So in case the high score was 100 and the user's current score is 200, then the new high score is 200, and the high score value in the local storage should also be 200. In order to handle the fact that the game is over, lives equals 0, we're going to reset the numbers of lives to 3, and we're going to reset the score to 0, and of course we're going to update the status line so that it will display the new high score in case there is a new high score, the new number of lives, and the new score. Let's check the game. First of all, as you can see, we have the high score available here. My current high score is 0. And now we'll start playing. As you can see, I've lost once, lost twice. And now, when I lose this life, then the score at that point will be the new high score. Let's play. So as you can see, I eliminated all of the lives I had. The game restarted, so we have score 0 and the number of lives is 3. But the high score was the score I reached in the previous game. Now let's see what happens if I play the game and I reach a lower score than 600. The high score remains 600. Congratulations, now you know how to use web storage to hold game data. And with that, we've completed section 4. In this section, we focused on going further into the game logic and adding support for various input devices. And in the end, we've also discussed about saving data locally in between sessions, regardless of which device you use. In the next section, we're going to discuss about testing and debugging the game. Hello and welcome to section 5. While in the previous section, we've worked on the code and the game logic, in this section, we're going to discuss about testing and debugging the game. In this section, we're going to focus on testing the final product in order to see if it works as expected. In this video, we're going to have an overview on the Chrome Developer Console. We're going to review the Chrome Developer Console features, and we're going to see how it can assist us in testing the game. In the previous video, we've completed creating the game, and this is our present state. Now, we want to see how we can debug the game and basically assist ourselves in finding problems during the development of the game. So for example, first let's open the console. Opening the console is pretty easy. We can either press F12 or we can right-click the mouse and choose Inspect. Here you can find various tabs. We're going to overview some of them. The main tab we're going to review is the Console tab. As you can see currently, the Console tab is empty. If we add to the code the console log command, we can add lines to the console and see various stages in our game. So let's start. We'll go to the Start Level function. And we're going to add here a console log command. It's going to state that the game has started. So now, every time the code reaches this point, it's going to add one line to the log which says start game. Next, we'll go to the lose life function. And we're going to add here console log lost a life. Since I'm going to test using the keyboard, I'm going to go to the keyboard section in the tick function and add console log keyboard left in the code which relates to the left movement, and we're going to copy it here and add it to the section which relates to the right movement of the pedal. Last but not least, we'll go to the check collision, and here, right after we add 100 points to the score after the ball collided with the brick, we write to the log that the brick was hit and the new score equals the score variable. Now, if we refresh the game and I start using the keyboard, you can see that whenever I click the right button, it adds the keyboard right line to the log. And whenever the same line is repeated over and over again, you can see that it collapses every line together. So we have 78 occurrences of the keyboard right. And if I click the left button, you can see that it adds the keyboard left line to the console. If I click the spacebar, we're going to start the game. It's going to add start game to the console. As you can see, I also hit a brick. So it stated that the brick was hit and the new score is 100. And since I lost a life, it adds the lost a life line to the console. Now if I continue playing, you can see that every time I hit a brick, every time I move left or right or lose a life or start a game, everything is added to the console. A useful piece of information in the console is the text on the right, which states the line in which this code resides. So for example, the keyboard right resides in line 161 in the index.html file. As you can see, in line 161, we have the console log keyboard right command. So this way, even if you write the same thing over and over in the console log, you can differentiate between the lines by using the information regarding the line from which it was called. Another useful feature of the console is the ability to call functions directly from the console. So for example, if I wish to add 300 points to my score, I can call the add to score function with the parameter of 300, and we'll see that the score updates. So as you can see, my current score is 300, and if I go here and I write add to score 300, click enter, you can see that the score updated to 600. So this way, I can call functions to see their effect on the game without needing to reach that certain part in the game. So this way I can test various functions without actually needing to reach that point in the code which calls that function. We'll open the console a bit and review some of the other tabs. In the Elements tab, you can see the HTML code, and you can see that every time you highlight a certain line, it states which part in the page it relies to. For example, the body relies to the entire page, the canvas only to the canvas part. The script itself doesn't relate to anything in the code. The Sources tab states which files were downloaded in order to run the current page. So we have the index.html page, and we have the CreateJS framework, which was downloaded from the CreateJS website. And these are the two files which were downloaded for creating this page. Network states the amount of time it took to load each one of the files required for running this page. The timeline is mainly used to test the amount of time it takes to load each part separately. And the Resources tab is used to show you saved data like cookies, local storage, and session storage. Now if we recall, in the previous video, we've added the high score to the local storage. So if we go to the local storage tab here, we can see the high score local storage with the value of 500, as you can see here. Congratulations! Now we've completed the overview of the Chrome Developer Console. In the next video, we'll discuss about debugging with breakpoints in Chrome. Hello and welcome to video 5.2. In this video, we're going to discuss about debugging with the breakpoints in Chrome. We're going to place breakpoints in various locations in the code and test the code while using these breakpoints. We have here the game open with the console on the right from the previous video. We'll go to the Sources tab and here in the index.html file we can see the JavaScript code. Now, if we wish to place a breakpoint in a certain location, we just click the line number on the left. So for example, if I wish to add a breakpoint in the lives -- command, I click here. As you can see on the right, the breakpoint has been added to the list of breakpoints. If I click other lines as well, you can see that they are all added. But we'll stick with just one breakpoint in line 110, lives --. Take notice that in your certain version of the code, it may not be line 110, so look for lives -- in the loseLife function. Now, after we place the breakpoint, we can run the game and reach the point where we lose life. So as you can see, in the moment the ball hit the bottom of the screen, we've reached the loseLife function. The browser is currently in pause mode. As you can see, it states here paused in debugger. If we take a look at the console, we can see certain things. First of all, we can see that we've reached the line lives --. We can see that the breakpoint here is highlighted and it states here that it's paused on JavaScript breakpoint. The call stack is used to show us which functions were called before reaching this command. So after a few inner CreateJS functions, we've reached our tick function, which called the loseLife function, and in the loseLife function we've reached the lives -- command. Now in order to continue from this point, we have two options. We can either click the play button, which will resume the script execution and the game will return to normal until it reaches this breakpoint again, or we can use the step over next function call button, which will let us skip one line at a time. This way, you'll be able to test your code one line at a time to see if there is a problem in one command or the other. If we click the resume button, as you can see, we've reached the game again. Now if we start playing and we lose again, we reach the breakpoint again. Congratulations! Now you've tested on Chrome using breakpoints. In the next video, we're going to discuss Firefox debugging. Hello and welcome to video 5.3. In this video, we're going to discuss about Firefox debugging. I've opened our game in Firefox. Now, let's open the developer console. As you can see, the console itself is pretty similar to the one in Chrome. The structure is the same, and if we start running the game, you can see that the log calls we've added appear here as well. So everything we've added in the console log commands appears in Firefox console as well. On the right side, you can also see the line from which it was called, similar to how it is in Chrome. Now let's take a look at the debugger. In the debugger, you can go to the file you want to debug, in our case the index.html file. This time, let's debug something else. Let's debug the brick hit. So we want the game to stop when the ball collides with a certain brick. So this will be our breakpoint. So let's start playing. As you can see, as soon as the ball hit the brick, we've reached the breakpoint. And here, similar to Chrome, we also have the resume button. Upon clicking it, the game will resume its previous state and continue running until it reaches this breakpoint again. We have the step over, which we saw in the previous video, that skips lines, that is used to skip commands one by one. We also have the step in if we want to enter a certain function. For example, in line 207, we have a call to the destroy brick function. If we click the step over button, we're going to continue to line 208. If we click the step in button, we're going to enter the destroy brick function, and we're going to see the commands which run inside that function. So in our case, the scale and the timeout. So all in all, the Firefox debugging is pretty similar to the Chrome debugging. The console log commands work in the same manner they do in Chrome, and the debugger, although slightly different, is similar in structure to the Chrome one, so it's pretty easy to handle one if you know the other. Congratulations! Now you've debugged on Firefox. In the next video, we're going to debug using an Android device. Hello and welcome to video 5.4. In this video, we're going to discuss about testing and debugging on Android devices. Now, the first thing I'm going to do is I'm going to open our game in Chrome on an Android device. So I have to make sure that I'm opening the game using the Chrome browser and not the stock browser on the device itself. Now you should go on your Android device to the developer options and enable USB debugging. Now you can connect the device using USB to your computer. After doing that, you can go to the Chrome inspect URL, which shows you the devices which are currently connected to your computer and can be debugged using Chrome debugging. So as you can see here, I don't have any device linked to my computer. So I'm going to connect it now. Now, as you can see, the device was detected in this tab, and it states that my LG device has Chrome running and with one tab open, which has the URL of the game we created. Now, if I click inspect, a new pop-up will appear, which will show me an exact duplicate of what the screen on my device is showing at the moment. So if I'll start playing the game on my device, you can see it here as well. Now, once you reach this stage, the debugging and the testing is pretty similar to what I showed you in the previous videos. So we still have the console here, and as you can see, we have the logs, the brick hit and the lost life log, and we have the resources and the timeline and the network and the sources. Basically everything we need. For example, to debug, we can use the sources tab, and to test the logs, we can use the console tab. Now, apart from testing on the device itself, I can simulate touch events right here on the computer, which will then be shown on the device itself. So you can either choose to test on the device and see what happens on the computer, or you can test on the computer and see what happens in the device. Congratulations! Now you know how to debug using an Android device. In the next video, I'm going to show you how to debug on iOS devices. Hello and welcome to video 5.5. In this video, we're going to discuss about debugging on iOS devices. We're going to use an iPad, and we're going to need to connect it to a Mac because only using a Mac you can debug an iOS device. So first of all, I'll show you the screenshots of what needs to be done on the iPad beforehand. Go to the settings menu on the iPad and choose Safari, like in the image displayed here. On the right side, you'll see an advanced button. Click it and you'll get the following menu. As you can see, there's an option called Web Inspector. Upon choosing it, you'll be able to debug your iOS device from a desktop Mac computer. So turn on the Web Inspector, like displayed in this screenshot, and now we'll move to the Mac. Now, in order to start the debugging session, we'll need to use a Mac. This cannot be done on a Windows computer, so we'll switch to our Mac computer, and we'll connect the iPad using USB to the Mac. We'll open a Safari browser, and then we'll go to the Safari preferences, and we'll go to Advanced. In the Advanced menu, you can see that we have a checkbox called Show Develop Menu in Menu Bar. Check this checkbox, and now you have it in the upper menu. Click Develop, and here you can find the iPad. Now, I open the link to our game on the Safari app on the iPad. So, as you can see, I can see the URL which is open in the mobile Safari app. Upon clicking it, I will get the debugging console, like I did in the Android debugging video, and like I did in the desktop debugging video. As you can see, we have the usual tabs, which are Elements, Resources, Debugger, and Console. Upon playing the game, you can see that I get console messages like Start Game, Brick Hit, Lose a Life. And this is done while I'm playing the game on the iPad itself. The debugger is also similar. In the Resources tab, we'll be able to add breakpoints to our code, so that when we actually reach that point in the code, we'll move to the Debugger tab, which will give us the information like we did in the Android debugging and desktop debugging videos. We'll get the call stack, we'll get any information which is available on that command, and other breakpoints in the code. So all in all, as you can see, the iOS debugging is no different than the Android debugging or the desktop debugging. Pretty similar. The main differences are in the way you connect to the device you are testing. Congratulations! Now you know how to test and debug on an iOS device. You have now successfully completed Section 5, Testing and Debugging of the Game. In this section, we've discussed about testing and debugging the game on various devices. In the next section, we're going to talk about wrapping up the game and discuss additional information which you may need in your HTML5 game development process. Hello and welcome to Section 6. In this section, we're going to talk about common errors which developers encounter during the development of HTML5 games. While in the previous section we've talked about testing and debugging on various devices, in this video we're going to discuss about common errors which developers encounter in the code, and we're going to discuss about solutions for these problems. During HTML5 game development, developers usually encounter similar errors during the development process. We're going to discuss about a couple of errors which developers usually encounter during CreateJS game development. Now, one of the first issues is the CreateJS version. Sometimes during the development process, the CreateJS version may change. For example, we're currently using May 21st version of CreateJS, as you can see, date here. Since then, new versions have been released. Usually developers tend to go to the latest version and implement it in their code, but sometimes it's not the best idea. APIs may change and the syntax may also change. So if you're working on developing a game and you wish to complete it, you should think twice before moving on to the next CreateJS version, and it may be best to remain with the version you started developing on the game. The two options you have is either save a local version of the CreateJS library and work with it during the development process, or never change the CDN URL which you are using during the development process. Another error which developers may encounter usually happens when they use external JavaScript files. During our course, we've written the JavaScript in the HTML file. Now, this enabled us to avoid any errors during the development process, but for larger projects, it's usually not a good idea to write the code inside the HTML file. So usually in an external JavaScript file, which you usually load in the head tag, and what usually happens is that developers don't write the onload event in the body tag, and since the canvas loads basically after the JavaScript file has loaded, then the page will basically not load, and if we take a look at the console, you can see nothing is loading. Now this is basically because the init function has not been called, so we'll add a call at the beginning of the code to the init function. And if we'll run the page again, you can see we encounter an error in line 379. Now line 379 trying to find the width of the canvas, and since the canvas loads after the JavaScript file has loaded, we need to make sure that the page has loaded completely before running any script. So in this case, during the course, what we did is we placed the canvas tag before the script. But when developing using an external JavaScript file, which will always load before the canvas, we make sure that the body tag has an onload event which calls the init function in that file, making sure that no code runs before the canvas has completely loaded. Another common error for CreateJS developers is the fact that they sometimes forget to add the stage update command. Stage update command basically refreshes the view and displays the latest state of the stage. Now sometimes developers forget to add that, whether to the tick function or to various locations where they made visual changes, and they don't see the visual changes that they made in the code. So if we forget to add the stage update command in the tick, which is called in every frame, we may reach a point. For example, take a look at the lives I currently have in the game. I have 3 lives. Start the game. Now I have 2 lives, a brick has disappeared, and my score is 100. That's because in the tick function I don't have the stage update call, and I rely on other stage update calls which happen at the beginning of the game and at the end of the game. So the progress of the game is not visible because I'm not updating the stage at any point, apart from the beginning and the end of the game. So as you can see, I can play again. The game runs in the background. Things actually happen. As you can see, the ball hit the bricks and everything disappears, but I'm not seeing the progress of the game. So it's important to make sure that the stage update command is called whether after you make certain visual changes which you want to see updated, or during any stage of the tick function. So we need to make sure that the stage update function is called whether after we make a certain change in the visuals or at any stage of the tick function. This way you don't have to deal with the stage update because it happens in every frame. Last error I want to talk about is the set bounds. Now, during the development of this game, we've had some generic functions. For example, our check collision function was pretty generic. The ball element sometimes hit the pedal and sometimes it hit the brick. So in order to make the function as generic as possible, I had to make sure that the hit element will be able to provide the function with its width, because the pedal had a certain width and the brick had a certain width. Since CreateJS doesn't provide the width and the height of a certain element out of the box, we have to set it manually. So whenever I create an object, for example the brick or the pedal, I had to use the setBounds function to state its width and its height, so I'll be able to use the getBounds function later on in the code to see what the width and the height of that element was. Had I not used the setBounds, I wouldn't have any way to know what the width of the hit element would be or what its height would be. Well done! Now we've reviewed some common errors in CreateJS. In the next video we'll discuss about troubleshooting. Hello and welcome to video 6.2. In this video we're going to discuss about troubleshooting. During the process of developing an HTML5 game, you may experience a few bugs which you'll need to troubleshoot along the way. Now in this course, we've talked about various ways to use the console to debug and view log commands while you're testing the game. Now it's usually recommended to use console log as much as possible during the development of a game in crucial points in the code which you consider problematic and may be the source of the bug you are currently experiencing. Now, when we've worked on the game itself, we've used console log to detect when the player lost a life, the keyboard was clicked, a brick was hit, the game started, etc. Now the console log can be used to see the ball speed or paddle speed in order to find specific bugs which you may not find in another method. Another thing which you can use to find problems in the code is to pause the browser in case of exceptions. Now usually when there are exceptions in the code, they appear in the console. But if you want to make the exceptions stand out, you can go to the Sources tab in the console and click on the Pause on Exceptions. This way, the script execution will halt in case of an exception. Let's see an example. If I add to the start level function code which may trigger an exception, for example, if I reference an object which doesn't exist, then once I'll start the level, an exception will be dispatched and the browser will halt. As you can see, the console highlighted the line which caused the exception. I can see the call stack of which function called the current function, and I can see more information regarding the exception in the Scope tab on the right. If you experience any specific CreateJS errors, it's usually recommended to go over to the CreateJS website and review the documentation to see that you are using that CreateJS object correctly. Congratulations! Now that we've gone over the troubleshooting section, we can move on to the next video, which is additional references and wrap up of the course. Hello and welcome to video 6.3. In this video, we're going to discuss about additional references to CreateJS and wrap up the entire course. Now, as with every framework, it's always recommended to visit the official website to always get the latest files and see the latest changes in each version. Now, the CreateJS framework is no different. It's always recommended to go to the createjs.com website. In case of any errors in the code, as discussed in the previous video, it's always recommended to visit the documentation section. Each of the 4 libraries, EaselJS, TweenJS, SoundJS, and PreloadJS, have their own documentation with examples and a list of the APIs. The blog section is also very recommended, as you can always get the latest news regarding the latest versions of CreateJS. Each time a new version is released, they write a post about the new version, including release notes for each one of the libraries. For example, during the recording of this course, a new version of CreateJS was released. In the blog post, they usually give links to the release notes themselves, in which you can see what was changed in that version. In case you are a Flash developer or a former Flash developer and you use Adobe Animate to create the CreateJS content, you can go to the CreateJS section, the HTML5 Canvas Documents section in the Adobe website, to get an overview of how to create HTML5 Canvas documents in Adobe Animate, which will then be exported to CreateJS projects, which you can expand on after publishing using Adobe Animate. Now, these documents usually relate to Adobe Animate, which you may find useful in case you want to create graphic assets or animations easily, instead of writing a lot of code to achieve the same thing. Last but not least, CreateJS on GitHub gives you direct access to the source code of the libraries, in case you want to see the logic inside the classes themselves, as well as the ability to inform them of issues you have found in CreateJS, for example, memory leaks or events not working, or various problems you have found in the code and or in the framework. The wiki section will also give you frequently asked questions, more articles and tutorials for you to review, additional videos, and more info regarding future development and the roadmap ahead. Congratulations, you have now completed section 6 of Mastering HTML5 Game Development. In this section, we've talked about wrapping up, and we've provided additional information for future reference. And with that, we've completed the Mastering HTML5 Game Development course. In this course, we've learned how to develop HTML5 games by creating a breakout game. Well done! I hope you enjoyed the course, and I hope to see you in other courses as well.